We're gonna go through a really quick question that was raised based on the previous video. So I was asked to show why the permutation, right, with replacement goes with this formula. Okay, why this is true, and like how we can like have like a visual representation of it. Okay, so this is pretty much like something elevated to something, right? So the way how I like to look at it, right, is a good example is permutations, right? So you know that n is the total number of items that you can choose from, right? And k is the number of items, you know, to group. Okay, so let's just give a quick example, right? Let's say that, you know, you have one dice, right? A dice have like 6 options, right? So that will be my n value. And let's say I want to know how many permutations are there if I group the dice. Let's say that I throw the dice twice and I record the result. Let's say the first try I get number 1, the second try I get number 5, right? How many different permutations or options will should I be getting, right? So if I just throw it like twice, right, and then record that. So I want to grouping by 2, so that's gonna be my k, right? So the way how I like to look at this, right, is like you have your first dice, right? So you say 1, right? And you have the second try when you throw the dice, right? So this kind of like looks like this, and this is like a really good way of like showing like all the different options that you will get, right? So the intersection of each of them is one option, right? Like let's say I throw like, you know, twice the dice, I'll get 1 1, 1 2, 1 3, and so on and so forth, right? Okay, so pretty much each of these ones represent like one permutation, right? Possible. So yep, there's all different options, and guess what? This is 6 times 6. That's the nice thing like about like and the way and the reason why is that is because, right, we, you know, our n is 6 and our k is 2, so the permutation is equal to 6 to the 2, which is equal to 6 times 6 equals 36. Okay, and the reason why it's like nice to look at this is because you can think about it as the area, right? The area is always like in square units, like meter square, for example. So it's like a nice way to represent all that area, right? So that's how we get that, right? And let's say that maybe now you want to throw the dice 3 times, right? So then it will be n to the k is equal to, well, you still have a dice has the 6 options, and because you throw it 3 times, you want to group the result that you get every time, right? So 6 to the 3. 6 to the 3 is equal to 6 times 6 times 6, or 6 to the 2 times 6. right? Why do I want to put it in this notation? Well, it's because we already found out what is 6 squared here, right? So what I'm gonna do is I'm gonna put every option in my vertical and the other options possibles in my horizontal. So this is 1, 1, 1, 2, 1, 3, all the way to 6, 6. And we know that here there's 36 different permutations, right? Because we just calculated that from the previous example, right? So we do a very similar process, right? But this time, and you only have 6, right? So okay, so you do like a similar process, right? So here it will be 1, 1, 1, 1, 1, 2, 1, 1, 3, so on and so forth. So intersections represent something, and we just had this like in a area format, right? You know, like cubic is like volume, but you can always put like in some sort of like understanding of area. So you have all the different options. You multiply that by 6 again, so you get like the cross-sectional area, and that's a simple way and like logical way to think about it, right? So, you know, 6 to the 3 is 36 times 6. So yep, that's a good way of like looking at this from a visual